Hello, coming to you today with Module 3, the second section, so 3.2 homework, and we're going to jump right into it. So again, Module 3 is our first look at probability. So with this problem, we're actually looking at a probability distribution. So in 3.2, we're introduced to probability distributions just in general, and then we focus on a specific type of probability distribution. So this particular problem is just a probability distribution in general. It's related to the number of dogs per household in a small town. So dogs represent your X values. Number of dogs represent your X values. And then what has happened is the probability for each X has then been calculated. So you don't actually have to calculate any probabilities on this problem. We're given this distribution and we're asked to find the mean, the variance, and the standard deviation. Now, in your lecture videos, they're going to show you the formulas for these, for solving these values. And the formulas aren't terrible, but it would require you to, create a table, of course, with these being your first two columns, and then creating another column for perhaps each X times each probability, and then so on. But there's a shortcut way to do this. So another way to state a probability, or another name for a probability, is a frequency or a relative frequency distribution. So what we're going to do is use our list, and we're going to put in the X values, and we're going to put in those probability values. And of course, if we're using our list, okay, first I got my calculator turned on, and if we're using our list, then we are going in the same, or to the same location that we used the list before by pressing stat. Remember back in module 2 where we had to use the list, we press stat. Let me get this glare off of here. I may have to scoot it down. I was trying to show you my keyboard, but in order to keep the glare off, I gotta scoot it down. Okay, so let me go back here. I'm on my home screen. All I did was press the stat key. So I'm gonna scoot it up, then I'll scoot it back down. So I press the stat key, and then of course edit is highlighted, which we want to edit, so we're gonna press enter. Okay, now I already have some items in here because remember we were doing or using lists back in module 2. So I'm gonna go up to the name and I'm gonna press clear, enter. And I'm going to go up to this name and also press clear, enter. Okay, so in list 1, I'm going to put the X values, the number of dogs, 0, 1, 2, 3, 4, 5. And then in list 2, I'm going to put the probabilities, 0.669, 0.208, 0.084, 0.021, got one too many decimals in there, 0.021. Okay, so sometimes you may have to slow down. You see how I just made that little mistake right there? 0.013, because you don't want to mess up 0.006, especially before catching it, or at least you want to make sure you catch it. If you do accidentally mess up, and I did somewhere, I haven't pressed enter there. Okay, now, so you want to always double check your values, making sure that you got them entered incorrectly, because if anything is put in wrong, that's going to mess up your answers, okay? All right, and so we're good there. So again, instead of using the formulas, I'm using my calculator. So I put the X values in list 1, I put the probability values in list 2. Now, I'm going to go back to stat, just like we did back in module 2, and I'm ready to calculate. So I'm going to go over to calc, okay? Now, what I'm going to be using this time is still number 1, okay? Which may seem weird because you're thinking, well, you got 2 lists though. Yes, I have 2 lists, but I have only 1 variable. It's still just 1 variable X. What's happening is I'm given the probability for each X. So it's still just 1 variable stats, all right? And we're going to tell the calculator to use the probabilities with those variables, okay, with the X values. So I'm using number 1. Okay, so my list 1 automatically is L1 there. My list is L1 by default, which is why you always make sure X is in list 1. Look at frequency lists. Normally we keep that clear, but this time I'm given a frequency list. Remember I told you probabilities, another name for probabilities is relative frequencies. So your frequency list is list 2. So I'm going to tell the calculator right here to use list 2. Now how do I do that? Let me scoot my keyboard up here. You see L2 right here in blue? That is the second function of this 2 key. So I'm going to press the second 2 key to select L2. And then I go to calculate. Okay? Now, the mean by default, this is the mean mu, but by default your calculator calls you mean x bar. So understand that this is the same value, okay? Your calculator will automatically call it x bar. And it says round to 1 decimal, so that's going to be 0.5. All right? Now, we have sigma, and they put a little subscript x there, but that's just sigma, okay? So sigma or sigma x, same thing from the calculator. So that is sigma x from the calculator. Now, notice that you don't see sigma squared. So what we're going to do is we're going to take that sigma value. I'm going to write it down so that I don't lose any of the decimals. I'm going to write every digit down, and then I'm going to square it so that I have the variance. Okay? Now, if I was to use the formula, I would actually get the variance, okay? And then I would take the square root of the variance to get the standard deviation. But using the calculator doesn't give me variance. It only gives me the deviation. So I have to take the deviation and then square that in order to have the variance. All right? So I'm going to take sigma x. I don't know why I put a little bar there. That is not what I meant to do. And it's not going away. Okay, there it is. I don't want to confuse you, so let me correct that. So sigma x, and that is 0.904992358. Okay, now when I actually enter the standard deviation, the sigma value here, I'm going to round it. But when I'm using it to get the variance, I want to use every digit. I want to use the original number. So I wrote it down because I knew that when I started typing on my screen, everything would vanish. Like, for example, exactly right there, 0.904992358, and I want to square that so that I'll have the variance, and that is 0.8. Okay. Then I have my standard deviation, which is just this number rounded to 1 decimal. It would be 0.9. Okay. All right, now the last part says interpret the results. So here they're just asking us to state the mean or the average, whatever it is, and the deviation. So on average, a household has 0.5 dog with a deviation of 0.9. So 0.5 dog with a deviation of 0.9 dogs. That would be D. D would be your answer there. Okay? All right. Now let's move on. Now, of course, after you use that frequency list, okay, for this problem, when you are back on this, you would clear that, okay? You wouldn't want to keep that there because you won't have a frequency list for every problem. Probably, honestly, just this problem. So you would, after you finish this problem, you would clear that. And how did I go to it again? I went stat and I went over to calc, and it was number 1. And I just made sure my frequency list was cleared out again, because usually it should be just clear. Okay, so that was a probability distribution. Now, the remaining problems here focus on a specific or special type of probability distribution. Okay, number 11 is our introduction to it. It's called the binomial distribution. So let me talk about binomial. Hopefully you've watched the lecture videos and you have an understanding of it. But a binomial distribution is simply a discrete probability distribution that has 2 outcomes possible, success or failure. So either you get what you desire or you don't. Like, for example, if your experiment was shooting or taking basketball free throw shots, let's say you're taking 10 shots, okay? You're taking 10 free throw shots, so 10 independent shots. And for any given shot, you have an 80% chance of getting it in, of making it. So this is binomial because there are only two outcomes possible. Either you make the shot or you don't, okay? Each individual shot that you take, because you're taking 10, okay? Each individual shot that you take is independent of each other. In other words, whether or not I make shot number 1 has no effect on if I make shot number 10, okay? They're independent trials. So a binomial distribution has a set number of trials. Each trial is independent of each other, and you have only two outcomes possible for each trial, success or failure. Okay, so let's look at this problem and see if we have a binomial distribution. So that is the question. And then we'll look at it with some problems. All right, so number 11, about 80% of babies born with a certain ailment recover fully. A hospital is caring for 6 babies born with this ailment. The random variable represents the number of babies that recover fully. Decide whether the experiment is a binomial experiment. If it is, identify success and specify the values of n, p, and q, and list the possible values of the random variable x. Okay? So it says, is this experiment binomial? So let's reread it. It says about 80% of babies born with a certain ailment recover fully. Okay? A hospital is caring for 6 babies born with this ailment. So either they recover fully or they don't. Okay? 2 outcomes possible. You got 6 babies, 6 individual babies, so 6 independent trials. Okay? So is this a binomial experiment? Yes, it is. Second part says, what is a success in this experiment? That the baby recovers. That would be deemed the success. Okay? And the success is always listed as P also when we get to that. All right, it says specify the value of n. Well, n represents the set number of trials. We have 6 babies born with this ailment, so n is 6. It says specify the value of p. Well, p represents the probability or the rate that a baby's born with this ailment would recover. The probability that a baby born with this ailment would recover. That's that percent. Anytime you're given that percent, that will represent your P. On all these problems that we're about to look at, that percentage will represent your probability of success. That's your P. Okay? We're going to change it to a decimal, make that 0.8. Then, if P is 0.8, the way that you'll get Q, because remember, P represents your success. The way that you'll get Q is you'll say 1 minus P. Remember, the total sum of all probabilities is always 1. Well, you only have 2 probabilities, probability of success or probability of your failure. So P plus Q together will give you 1. Therefore, if you know P, then you can easily get Q by saying 1 minus P. So if P is 0.8, then Q is 0.2. Okay? And then lastly here, it says list the possible values of the random variable x. Well, x represents the number of successes. Out of those 6 babies, you could have 0 that recover fully. You could have 1 recover fully, 2 recover fully, 3 recover fully, 4 or 5 or 6. You can't go past your total number 6 because that's your total number of trials, total number of babies. So you could have all 6 of them recover, all the way down to none of them recovering. So the possible values of your random variable x would be 0 through 6. Okay? And this is a binomial experiment. So that leads us into the binomial formula when we get ready to actually calculate binomial probabilities. Here is the formula that your lecture videos went over and talks about in detail. Now I'm going to show you how to apply this formula, but I'm going to actually use the calculator shortcut methods to make your work less longer, or to reduce your work time. But this is the formula, okay? This is the formula for calculating a binomial probability. Now this n choose x, I want you to understand that that is the same thing as n choose r, okay? R and x are interchangeable. So you may see NCR, you may see NCX, and that is if you're using the formula, okay? So we'll be looking at some probabilities now. And I'll just make a second video here for 3.2.